Good morning, everybody, once again. I want us to tackle this question here. And the question says that a quantity P varies inversely as the square of another quantity L. When P is equal to 0.625, L is equivalent to 4. Find P when L is 0.2. So, a quantity P varies inversely as the square of another quantity. So, in variation, when a quantity is varying inversely as another, or the, okay, let's make it short. So, for example, let's say the quantity P, as we've been told, varies inversely. Inverse means something 1 over something for inverse. Like we want to find the inverse of P right here. Inverse of P is just 1 over P. So we are being told that P varies inversely as the square of another quantity, and the quantity is L. So if P varies inversely, what we have to know that P is equivalent to 1 over L. But L is not just L, it is L squared. So L squared. So it's not, just a demonstration. So for inverse, the sign for inverse is this one. So P varies inversely as the square of L. Hope we got that. Then, now, for us to move this one so that we can replace it with equal sign, what we need to do is to replace here we introduce what we call a constant. We introduce a certain constant so that we can remove the sign for variation, so that we may come back and then find the relationship between P and L. So the relationship between P and L we only get by introducing a constant between P and L. So for us to remove this one, we can say P can be equivalent to any constant. A constant can be any letter of your choice, but can't be the letter same to this one for confusion. You can use the capital P or capital L and then small l as a constant, or a small p as a constant, but it brings a lot of confusion. But now what you need to do, you need to find a constant. So let's say my constant is k times 1 over L squared. So I've introduced a constant k to remove this variation, so that I can now say that P is equivalent to k over L squared. So whenever I have the equation that connects the two, P and L, now I can use that equation now to find any solution of another if given one. When I'm given P and I don't have L, now I can replace here and find L. But before that, now K is a constant that I've introduced. And then there's information that I've been given, the first information that I've been given that connects the two. I've been told that a quantity P varies when P is equal to 0.625, L is equivalent to 4. So if P is 0.625, L is equivalent to 4. What's the connection between the two? So for me to find the connection, I just come to my equation here and say when P is 0.625, so P can be placed to this equation here, 0.625 here is equal to K over L squared. So L is 4. 4 squared is 16. So what am I trying to do? I'm trying to find the value of K that give us that constant for us to find the inverse, for the variation. So I'll just cross multiply because K, this one is just over 1. So I will just multiply. So K is equal to 0.625 times 16. So this will give me the value of k. Say that in my next expression, I won't have to write the constant k, because k is just a constant. So what do I do? I just take 16 times 0.625, and then I find it is 10. So k is equivalent to 10. It's equivalent to 10. So the equation that connects the two without k is just p is equivalent to 10 over L squared. So that's the connection that connects the two without the k, because the k is a constant, and I'll find the constant to be 10. Now, if the constant is 10, now I have the equation now that connects the two. So I've been given the value of L, and I don't have the value of P here. So I'll be trying to find the value of P. So what do? I will just say P is what we need. So P is equivalent to 10 over L squared. L squared is 0.2 squared. 0.2 squared. So that when I square, when I work out 10 divided by 0.2 squared, I got 250. So P is equivalent to 250. Equivalent to 250. So that's the value of P when L is 0.2. And that's how we do about the variation. And this one was just our inverse variation. We have the other one, which is direct. We have direct variation. Direct variation now, for example, we can say P varies directly as the square of L. So if varies directly as the square of L, it just varies as L squared. P varies directly as the square of L. Then the same thing you will do. You will introduce a constant. Then another part, in any type of variation, we have the partial variation. So we'll say P varies partly as the square of L and inversely as. So the partial variation combines both the inverse and the direct variation. So thank you for watching, and thank you for everything. Please follow me and like, comment, and I'll be